Hi everyone, welcome to my YouTube channel Take Data Engineer. So now we will start this series of streaming data. Okay, we have already seen lot many batch processing, how Spark PySpark handle the batch data. Okay, so now in this series we will see how streaming works and what are the concept which is required to understand the streaming data. So this is basically nowadays most of the projects and company are working on the streaming data. Okay, so earlier most of the company working on you can say batch data, where they have the data in the some db postgres or some s3 or object storage or data lake or data warehouse anywhere, and based on some transformations and some like some different logic, we are either transforming or migrating data from one place to a different place in batch mode. Okay, but in case of spark streaming, the data generate in real time, and we have to consume that data, we have to process the data, and we have to store also. Okay, so there are many difference between streamings and batch mode for processing, storing, and capturing the data. So we will understand how a spark streaming box and what are the technology and tools which is required to understand the streaming data concept. Okay, so now start with the spark streaming. So streaming data refers to data that is continuously generated and delivered in real time. Okay, so often at high velocity. So some data, so in batch mode what happens, so batch mode data is there in the static condition in some storage location, either object storage, you can consider a s3 or any postgres db or any different db. Okay, and we are taking the data and then we are processing and we are storing again, so that is called batch mode. Okay, but in case of real time streaming data, you will get the real time data. Okay, with the high velocity. So unlike batch data, which is collected and processed in the chunk at scheduled interval. Okay, streaming data is processed as it produced. So streaming data is why it is different from the batch, because whenever the data got produced, that time you have to process the data. Okay, so this allow for immediate insights and actions based on most current data available. Okay, like sensor data or some, you can see live streaming, so match we can see the Hotstar or any live streaming whatever we are doing in the YouTube. So that all are the example of streaming data. Okay, so key characteristics of streaming data, so that is one is the real time. So data is produced, transmit and processed instantly with minimum latency. So there should not be any latency. So when data got produced, you have to consume the data and you have to transmit that data also. So continuous, the data flow is data is ongoing rather than a static or discrete. Okay, so in case of streaming data, the data is continuous. Okay, how high value, like often generated in large quantity. Streaming data can include sensor readings, financial transaction, social media feeds, and many more. Okay, then variety. So variety means the data whatever coming from the source, they have multiple format. Okay, like log, matrix, sensor output, and structured, semi structured, and unstructured. So there are multiple variety of data. So streaming data have multiple concept like real time, continuous, high volume, variety, and all. Okay, so in this video basically we will cover the theoretical topic, and then we will further move to the technical or any programmatical concept if required, we will explain that also. So you can consider, you can see that example of streaming data like sensor data. So information coming from IoT sensor. Okay, device like smart thermostatic or wearable fitness tracker, we have watches, so that are the example of that. So whatever the data got generated from that, you have to analyze the data in the real time. Okay, so how you are consuming the data, how you are transmitting the data to the like destination and all, and whatever the analytics you are getting from the data, you have to uh, you have to display that also. Okay, now coming to the social media feed, like post, tweets, and comments that are continuously being created and shared. Like then other is the website analytics, like user behavior data, page view, click, or whatever the action user takes on that particular website, that is also the real time data. Then financial transactions, like a stock market, a stock trades, credit card transactions, or cryptocurrency transactions are happening constantly. So these are the example of streaming data. So we understand what are the streaming data, what are their characteristics, and what are the example of streaming data. Now understood the, we can see that what are the technology for handling the streaming data. So there are multiple technology to handle the streaming data, but we will more focus on Kafka and Spark streaming. So basically we are handling through Spark, so we will see the Spark only. Okay. So to process and analyze streaming data, specialized tools and technology are used. Like there are certain tools like Apache Kafka. So Kafka is one of the tool, a distributed event streaming platform that handles high throughput and data feed. Okay. Then Apache Flink. This was also one of the framework for processing real time data with low latency. Then Apache Spark streaming. Okay. So a component of Apache Spark for processing live data streams. So we have batch data, and we have processing the live data, like we have real time data also there. Amazon Nexus. So AWS, we have services like Nexus, so which manage services for real time data processing. Okay. So in other cloud also, like we have GCP, we have PubSub and all, and we have in Azure also we have. Okay. Azure services for handling the real time data. So we can see the use cases. So what are the use cases based on this real time data? So like real time analytics, so understanding the customer behavior in real time, such as tracking user interaction on website to provide the personalized recommendations, monitoring and alerts, or whatever the IoT data, like managing processing data from the connected device to track the environmental condition, traffic flow, or any machine performance. So these all data are the examples of I can say streaming data. Okay. So why this is required? So streaming data is crucial in application that require timely or dynamic. So if you have, you don't have the time to uh, get insights from the data, you need to take any action based on the real time. Then you need to read the streaming data, and you need to whatever the transformations or action you need to perform, you can perform, you have to perform in the real time. Okay. So before proceeding further with the Apache Spark streaming, we can understand what is Apache Kafka. Okay, so Apache Kafka is a distributed open source streaming platform designed for building real-time data pipelines and streaming application. Okay, so it is primarily used for handling high throughput, low latency data stream. Okay, so it was basically that developed by LinkedIn, and later it was merged with Apache Software Foundation as a open source. Okay, so there are certain concepts which we have to understand before writing the code, or before understanding how we are getting the data, how we are consuming the topics, how we are consuming, how our producer, consumer, broker system works. So first we will understand the Apache Kafka architecture. Okay, so how Kafka works? First, you have to understand the producer. So producer is a application or component that publish the data to Kafka topic. So there are certain things which will publish the data, like it's like a sensor data. It send it to the Kafka. It generate the sensor data. It's like a producer. So consumer is an application or component that subscribe to a Kafka topic. So there is a Kafka topic. So what producer will do? Producer will take the data, and that is stored to the Kafka topic. What consumer do? Consumer take the data from the Kafka topic and process the data produced by producer. Okay. Consumer reads the data from topics and can process it in the real time, like a real-time analytics engine or microservice that process event for triggering actions. Now that is what is broker. So a Kafka broker is a server or instance of Kafka that store data and services both producers and consumers. Okay, so broker was nothing but it's like a server. Okay, so for accessing the data from any topic, you have to mention the Kafka broker. It's like a server details and all. Like what is the server details for getting the, you can say, particular topic and all. Okay. So a Kafka broker is a server or instance of Kafka that store data and server both producers and the subs both producers and consumer. So a Kafka cluster is made up multiple servers. So if multiple servers combine, it make as a Kafka cluster. Okay. Now coming to the topic. So topic is nothing but logical channel category which produced to which producer sends the data. It's like nothing but you can say consider it as a logical channel. Okay, so there is a topic where produce sends the data and consumer read data from that particular topic. Okay, so topic allow for data organization and Kafka support multiple topics. Okay, so if you're processing log from a web application, you might have a, so topic is nothing but it is like based on the domain specific, you can say. So there is, suppose it's a web based topic, or sensor data have sensor topic, or finance data have finance topic, marketing data have marketing topics, sales data have sales topic. So if you have different domain, you can create a different topic for that. Okay, so that you can consume data from that particular topic based on your requirement. Now coming to the partition. So a partition is nothing but a subdivision of topic. So each topic is split into one or more partitions, and each partitions can be stored on a different brokers. Okay, then partitions are primarily unit for like you can say scalability and parallelism in the Kafka. Okay, so you can understand like how Kafka allow horizontal scalable, or partitions are order, how your data is getting processed. Okay, so partitions are order, like partitions are order, meaning that message in a partitions have an order sequence known called offset. Okay, so if you read any topic, so there are certain offset, like from 0 to 10. If you are reading the data from 0 to 10, again if you are next time you will coming, you will read the data from offset number 11 to 20 or so on, based on your requirement and all. Okay, so you can mark your offset as the latest or earliest. So based on whatever what types of like you can requirement you have, based on that you can access the offset. So offset is nothing but a unique identifier for each record within a partitions. Okay, like partitions 1 have offset from 0 to 100, then again partitions 2 have 100, 0, 1 to 200, something like that. So it's nothing but it's like a, for accessing any record you need a unique identifier. Okay, so it indicates the positions of a message in a partition. So consumer uses offset to track with message they read. Okay, so Kafka consumer, the start from the any point, enabling is a you can say Kafka offset. So Kafka keep track of offset, which means that consumer can resume reading from where they left off after a failure. So suppose you are reading a Kafka topic, and you have read it from 0 to 100, and after that because of certain bad data or any other issue, your system got failed. So next time he'll come and he'll consume that your topic, so it will start from the offset number 10. So for fault tolerance or any recovery things, we require the offset for each particular partitions. Okay, then consumer group. So consumer group is nothing but it's a group of consumer working together to read from a Kafka topic. Okay, so now understand the what is zookeeper. So zookeeper is used by Kafka for distributed coordination and management of the Kafka brokers. So zookeeper is nothing but it's like a watch services, which is basically manage brokers, maintaining metadata configuration, managing consumer group offset. So zookeeper is like a watch services. Okay, so Kafka is moving towards replacing zookeeper with a own sequence mechanism, k raft mode. Okay, so that is the new thing which is coming, so that is replacing the zookeeper. But Apache zookeeper is nothing but it's like a it's used for distributing coordination and management of the Kafka broker. So different brokers we have, so how it is getting coordinated with each other and managing the metadata configuration consumer group, we require the certain services which is called zookeeper. Okay, So how Kafka work basically? So there is a producer, it produced the data, it produced to the topic. Then there are multiple brokers. Under broker we have partitions. Then consumer, what it will do, it will take the data from that particular topic. So producer send data to Kafka topic. Kafka topics are divided into partitions, and each partition store a subset of the data. So Kafka store data on brokers, and each brokers may have multiple partitions. So consumers subscribe to topics to process the data. So simple way you can understand, producer produce the data to the topic, consumer consumes the data from them, and the each topic is divided into multiple brokers, and broker have the different partitions. Simple. So consumers subscribe to topic to process the data, and multiple consumers can work parallel through consumer groups. Okay. So producer sends data to Kafka topic. Each message is appended at the end of partitions. Kafka brokers store that this deep message and assign them to unique object, and consumer fetch message from the topic, and it basically based on the object it will take the data. Okay, so this is the architecture for producer, topic, broker, partition, and consumer. So most of the time theoretical question also getting asked from that, how basically the architecture and how Kafka works. And in next topic we will see how we are handling the fault tolerance, recovery mode, how we are set up, how we are reading the Kafka topic, how we are adding to the console or different system. We will understand each and everything. Okay, so thank you, thanks for watching.